Hi students, good day everyone. This is Vanthana from Department of Computer Applications, SFR College for Women, Sivagasi. Now, I'm going to take you a lecture on the topic Internet Protocols, UDP and TCP. These two protocols run in the transport layer of our OSI model. First, we are going to see briefly on UDP, that is User Datagram Protocol. As the name says, here all the data transfers are in the form of datagram, that is packets, and UDP is a connectionless protocol. That means before sending any data to the receiver, there is no need to establish any connection prior. In UDP datagrams, there is an 8-byte header followed by the payload, that is our data. In the 8-byte header, that is 32 bits, there are 4 fields: source port, destination port, UDP length and UDP checksum. Source port is nothing but sender's source port address and destination port is nothing but receiver's port address. Here, source port is also needed when reply is sent back to the source by copying it to the destination port. Length means the amount of data in 8-byte header plus our data. So 8-byte header plus data, that will be stored in the length field. And checksum field is optional. It can be stored as if not computed. Then what UDP cannot do means it cannot do flow control, error control and retransmission upon receipt of a batch segment. So all that is up to the user process. Then what UDP can do means it just provides an interface to the IP protocol with multiplexing multiple processes using the ports. Then where UDP is used. UDP is generally used in many applications, but for simplicity, we are going to see only 3 applications: client-server situations, DNS, and real-time multimedia applications. First, we are going to see remote procedure call, that is client-server situation. What is client-server? It is nothing but sending a message to a remote host and getting a reply back. So, we can compare this process just like making a function call in a programming language. That is, when a process on machine 1 calls a procedure on machine 2, let machine 1 be the client and machine 2 be the server. So, the calling process on machine 1, that is client, is suspended and execution of the called procedure takes place on machine 2, that is receiver. Here, information can be transported from caller to the callee in terms of parameters and can come back in terms of procedure result. But this message passing is invisible to the programmer. This technique is known as RPC, that is client server message sending is compared to the function call in a programming language. This technique is called as RPC. So for these communications, UDP can be used. That is for this message passing, UDP can be used. For RPC, the client program generally needs a simple procedure called client stub and the server needs a procedure called server stub. So these two library procedures are compulsorily needed for RPC. So RPC and UDP are a good fit. That is, it does not mean that UDP is compulsorily for RPC, but UDP is a good fit for RPC. So it can be used for RPC. Here, these are the step-by-step execution of the RPC. First, client 1. Client 1 just calls the client stub. So the client stub, it packs the parameters needed into a message and makes a function call to the OS, that is kernel, to send the message. Then in step 3, the kernel sends the message from the client machine to the server machine. In the step 4, the kernel passing the incoming packet to the server stub. That is, the kernel in the server machine passes the incoming packet to the server stub. In step 5, the server stub calls the server procedure by unmarshalling the parameters. That is, Client step packs the parameter into a message and the server step unpacks the messages into the parameters. This process is called unmarshalling. So marshalling means packing the parameters into a message. Unmarshalling means unpacking the message into your parameters. That's all. So these are the steps in RPC. That's why client and server communications can be sent as such as a function call in a procedure call programming language. So here UDP can be used for this type of transmission. Next one is domain name server. In this application, we can use a UDP packet to know the IP address or to know the host name by sending a UDP packet to a DNS server and waiting for the reply. So just like that, to know the IP address or host name, we can use the UDP packet in the domain name server applications. Next, the third application we take for an example is multimedia application. Here, according to UTP, another protocol called RTP, that is real-time protocol, is also used. RTP can be used with UDP to carry out real-time media applications. So, the position of protocol in the protocol stack and the packet nesting is as follows. Here, the RTP is placed on the top of the UDP protocol. That is, RTP is mainly for multimedia application. So in the packet nesting, first there is a UDP header, and in the UDP payload field there is a RTP datagram. The RTP datagram, there is a RTP header and RTP payload. So like that, the packet nesting is in the UDP. In the RTP header, there are 32 bits that contains many fields. The first field is a version, VER, it is used to denote the version, and then P, it is used to denote padding. That is it is used to indicate that the packet has been padded. It is a multiple of 4 bytes, and then next, X bit indicates that the extension header is present there, and CC indicates how many contributing sources are there. That is how many audio contributing sources, how many video contributing sources. That is, multimedia application is nothing but combination of audio, video and text. So how many contributing sources means how many audio, how many videos, from where the data are available. So to maintain that count, CC is used. M indicates the market bit. It is used to mark the start of the video frame or audio frame. And then payload type indicates which encoding algorithm is used. That is for video or audio, MP3 or M4, etc. Sequence number. Sequence number, we all know that it is a counter. It is incremented for every RTP packet that is sent. It is also used to detect lost packets. And then the timestamp field, it is used to reduce the jittering. Jittering means voice and audio are not coincided. So audio is in separate line and video is in separate line. So there is no coincidence between audio and video. That is called jittering. So in order to reduce that jittering, timestamp field is used at the receiver by decoupling the payback from the frame arrival. Then the synchronization source indicator field is used to multiplex and demultiplex data to a single data. So just for multiplexing and demultiplexing, this field is used. Then contributing source indicator is used when mixed stream is present. That is, there is audio, there is video, that is text. So lot of sources is there in the data means contributing source indicator is used. We already see the field called CC. It is used to indicate how many source indicators are there. And then there is also another protocol in RTP called RTCP. That is, it is a sister protocol. RTCP means real-time control protocol. It is just used to handle feedback when there is delay, jitter, congestion or bandwidth. So for feedback purpose, we can use RTCP, and also for synchronization and the user interface. But it is not used to transfer any data. It is just for feedback, synchronization and the user interface. That's all about UDP. Then we are going to see about TCP, Transmission Control Protocol. TCP is a connection oriented protocol, unlike UDP. We all know that UDP is a connectionless protocol, but TCP is a connection oriented protocol. That is, before sending any data, we have to set up a connection. As it is a connection oriented protocol, it provides a reliable end-to-end byte stream over an unreliable network. In TCP, we are going to see first TCP service model. So in TCP service model, both the sender and receiver must create an endpoint called socket. So sender also must create a socket and the receiver also must create a socket. Each socket has an individual socket number. That socket number is nothing but the IP address of the host and the 16-bit number called port. So an IP address plus port, these cumulatively form a socket number, and a socket can be used for multiple connections at the same time. At the same time, a socket can be used for multiple number of connections. In port number, particularly the port number below 1024 are reserved. These are used for some standard services. So these are called well-known ports. In this table, some of the examples of the well-known ports. First 21 is for FTP. So for file transfer, the port 21 is used. And for remote login, 23 is used. And for email, 25 is used. And for TFTP, that is trivial file transfer protocol, 69 is used. Like that, below 1024 are all reserved for standard services. These port numbers are attached to their corresponding daemon at the boot time itself. In TCP service model, all the TCP connections are full duplex. That is, the data is transmitted in both directions. That is from client to server and server to client. That is from sender to receiver and also from receiver to sender. And also the connections are point to point. It means that each connection has exactly 2 endpoints. This is the main concept of connection oriented protocol, we all know. Then TCP does not support multicasting and also broadcasting. As it is a connection oriented, each connection must have 2 exactly endpoints, that is one source and one destination. So there is no need for there is no provision for support for multicasting and broadcasting. Then TCP connection is a byte stream, not a message stream. That is, there is no boundaries for the data. For example, if the sending process has 512 byte to send means, that is, if the sending process has 4 512 byte to send to the receiver means, then this can be sent as at a stretch as 4 512 byte or as 2024 byte or as 1 2048 byte. So there is no boundaries. Here there are 2 examples, 2 diagram examples. First diagram is the data is sent as 4 512 bytes and the second diagram is the data is sent as 1 2048 bytes. So here the data is in the form of byte stream and not message stream. Then when an application passes data to TCP, it may send immediately to the receiver or it may buffer it. One last feature of the TCP service is urgent data. If a user wants to send any urgent data means the receiver has to take immediate action on that data. That is, immediately the receiver has to receive that data. That type of data is called as urgent data. This urgent data can be specified by using urgent flag. If an urgent flag is set means the data set by the sender is the urgent data. This even causes TCP to stop accumulating data and transmit everything it has for that connection immediately without any time delay. It can send immediately all the data to that particular connection immediately. Also, on the receiver side, when the urgent data is received, the receiving application is interrupted. The receiving application is interrupted so that it can stop whatever it was doing and read the data stream to find the urgent data. So this type of provision is also available in the TCP service model. Then we move on to the topic TCP protocol. Protocol is not in TCP protocol, the data is exchanged in the form of segments, and the segment consists of a fixed 20 byte header. Each segment including the TCP header must fit in the 65,515 byte IP payload. And next, each network has a maximum transfer unit. Generally, it may be of 1500 bytes. And the main protocol used here is sliding window protocol. What is sliding window protocol? Here, in sliding window protocol, when a sender transmits a data, it starts a timer. So, before the timer ends, the receiver has to send reply to that particular data. Otherwise, the sender retransmits the data. The main concept here is the reply from the receiver is in the form of piggybacking. Piggybacking means attach the acknowledgement along with the ongoing data. That is called as piggybacking. So, when the segment arrives at the destination, the receiver sends back a segment bearing an acknowledgement number equal to the next sequence number it expects to receive. For example, if the source sends the data segment 1 means, then the receiver sends the acknowledgement as acknowledgement 2. It means that the next data expected is sequence number 2. If the sender's timer goes off before the acknowledgement is used, that is already I said, then the sender retransmit the segment again. Then the TCP segment header, as usual, it is of 32 bits. It contains many fields. First field, 2 fields are well known, source port and destination port to indicate the sender port address and the receiver port address. And also sequence number and acknowledgement are also usual thing. Sequence number, it is used to number the packet, and acknowledgement number is used to indicate that I had received this packet number. And then TCP header length tells how many 32-bit words are contained in the TCP header. Then next comes a 6-bit field that is not used. It can be used for some other purpose. Next comes 6 1-bit flags. Each flag can be used for specific purpose. First flag is URG. URG I already told it is an urgent flag. If it is set to 1 means the data is urgent. This data is used to indicate that this data is an acknowledgement. So if ACK is set to 1 means that data is an acknowledgement data. Then next field is PSH. We already see that upon receiving a data, the TCP can either send it to the receiver or buffer it. To indicate that type of transfer, PSH bit is used. PSH means pushed data. That is, if PSH bit is set means the TCP must send the data to the receiver upon arrival. It must not buffer that data. If PSH bit is 0 means the TCP can buffer the data and further it can send it to the receiver anywhere, anytime. Then RST bit, it is used to reset a connection. SYN bit, it is used to establish connection. And FIN bit, it is used to release a connection. And also we all know that it is a checksum bit, it is used for extra reliability. And also there are other options fields too. And then also there is data fields too. We are going to see TCP connection establishment. The TCP connection establishment is a 3-way handshake process. That is, if sender and receiver are going to establish a connection means sender say hi and then the receiver say hi and the sender say hello. This is a 3-way handshake method. So to establish a connection, both the side has to get ready. First, the server passively waits for an incoming connection by executing the listen primitive. Then on the other side, the client executes a connect primitive to make a connection to the server. While the connect primitive is executed by the client, it sends a TCP segment with the SYN bit on and acknowledgement bit off to the server and waits for the response. If there is any server with a listen primitive means, then that connection can be immediately accepted by using the accept primitives, or otherwise the connection can be rejected using a RST bit. So the connection can be either accepted or rejected. So this is a 3-way handshake methods. Once again I repeat, the server first executes the listen, then the client sends the connect. If the server is willing to accept means the server sends the accept primitive, otherwise RST to reject the connection. Here, a simple diagrammatic example for the connection establishment process. Host 1 is a client and host 2 is a server. So host 1 first makes the connection to the host 2 by using SYN with the sequence number X. So for connection request, the acknowledgement is 0. That's why there is no field for acknowledgement in the first packet. From host 2, it accepts the connection. So SYN sequence number is equal to Y and acknowledgement is equal to X plus 1. This is the sliding window protocol piggybacking. That is, the acknowledgement number is the sequence number of the next expected packet. So host 1 responds it with the sequence number X plus 1 and acknowledgement number Y plus 1. So this type of handshake method is used in the TCP connection establishment. And then the last one is TCP connection release. For the connection release, the main bit set is FIN. FIN is used to denote that the connection is going to release. When the FIN is acknowledged, then that particular direction is shut down. But data may continue to flow indefinitely in that other direction. When both the directions have been shut down, then the connection is released immediately. Normally, there are 4 TCP segments needed to release a connection. One FIN, one ACK for each direction. Also, I had given an assignment according to that video, that is compare and contrast TCP and UDP. That is differentiate TCP and UDP. Students, please reply for the assignment. Thank you.